So this is me. I am a superhero. There was a HVAC unit that was on a loading dock. It fell off. It cracked open. The radioactive refrigerant sprayed on me, and I became Captain Heat Pump. So I live right here in Greenfield. I've worked on all things energy for 4 decades, and what has happened in recent years is I realized that we've been making really nice buildings, but the mechanicals weren't very good, and I started focusing on that, and then later that's zeroed me in on heat pumps. So I'm mostly advising people at either residences or businesses or schools or bigger places on how to convert buildings from fossil fuel to heat pumps. And there's a whole bunch of different ways, and a lot more ways than a lot of you may think, that you can convert a place to a heat pump. So, and I have a habit of looking at the whole building, called whole systems thinking. You have to think about the whole building. Don't just grab a piece of equipment and throw it on a building, but know what you're doing about the whole building. And you should always get your building well insulated as part of the process of converting to heat pumps, so we size it right. So, and this is the only things we're going to talk about today. Just a few things. So, now, here is how a heat pump roughly works at a given temperature outside. You get 1 unit of electricity going in. You get 2 units coming from the environment, either the ground or the air, or a body of water or something. Then you get 3 units of heat out. So you're getting, what's this equivalent to for a boiler? A boiler, you put 1 unit in and you get, at best, 90% of the energy back out. This thing gets 300% of the energy that you put in. So you pay for 1 unit of electricity, and you get the equivalent of 3 units if you were heating your house with resistance electricity. Okay, so where are the 3 units, the 2 units of energy coming from? I just told you, where is it? This is where
Air.
The air. That's the environment. That means, how did that environment get any energy in it?
The sun.
The sun. So it's renewable energy. 2/3 of it is renewable energy just to start with. So this is reflecting the thing. Some people say, well, you're using dirty electricity to make clean energy. How can that be? Well, 2/3 of it is not it's energy you're not paying for, and that the environment isn't paying for in a negative way. So that's one thing to know. And then in this state, all the electricity sold in this state has an ever-increasing percentage of renewable energy required to be part of it, to be sold in the state. So more and more, the energy will be cleaner and cleaner. And if you go to an all-electric kind of situation, we're heading toward an environmentally benign way of heating and cooling buildings. So does that make sense? Maybe that's old news to you, but it's always good to emphasize that. So how does this all work anyway? I mean, how do you make, what we're doing is we're taking cold air and we're making our house warm. Now, what direction does heat go normally? No, heat does not go up.
Oh, that's right.
Hot air rises, but heat does not rise. Heat goes from hotter to colder. Hot air rises. Heat rises. That's normally in every one of my talks. I have this whole long thing about heat not rising. And the problem is, if you think of a heat rising, do you insulate your balcony floor? Oh no, the floor is going to stay cold, stay down, heat's going to stay up. That's not right. You've got to insulate everything. So know that. So So, but heat goes from hotter to colder, so how in the world are we getting heat to go from colder to hotter? It sounds like we're working against nature.
Well, we are. That's why we have to put electricity in.
No, it's another thing, actually. So there's a spell that you can say, which is hedium and massium transferium. It's from Harry Potter, and this is the way you get this to work. It takes both of these things, heat transfer plus something to do with the matter. And I'm not going to go into detail much about this except to, so I want everybody to stand up. Okay, now pair off, and you can either touch each other or not touch each other when I ask you to do this. But if you're comfortable shaking hands, because of COVID you might not want to, then everybody shake your hands. If you can't, then hold your own hands like this. Okay, now keep your hands together. What do you feel? You feel warm. Warm or cold? So that is conductive heat transfer. It's between across a surface to surface kind of thing. That's conduction. Now blow over the top of the other person's hand. And don't get to, or your own. Don't get too excited. Okay, that's convective heat transfer. Now everybody look at the person that you are paired with. And look at the person you're paired with, and the ones with your masks you'll just have to pretend. And smile. That's radiant. That's radiant heat transfer. Okay, so those are the 3 forms. And okay, now radiant is different because it doesn't heat up the air in between, except for a couple of you I noticed. But, it doesn't heat up the air in between, but it heats the surfaces directly. And the other way you can make energy move from one place to another is like taking a cup of water, hot water. You take it and you take it from here to here. Or if I take this from inside my house from inside of my house to outside, I'm taking thermal energy out of my house, but it's not heat transfer. Okay, so that's the distinction you need to know for this next picture. And mostly I do that to make people realize that there's no silly questions because I've already set the bar really low for what's silly. So we'll skip that. Okay, now here is a erroneous drawing of a heat pump cycle. So what you've got is a coil outside and a coil inside. This is those things you see hanging on the wall. This is the thing you see sitting out beside your house. And there's a compressor that works between these and does something to this fluid that's going from there to there. Okay? And the long and the short of it is, the thing that's missing is there's a valve that reduces the pressure here. And this is why the whole thing can work. And you drop the pressure down, it makes this stuff really low pressure. And what happens is, it makes it really cold. And it makes it colder than the outside. And so the energy goes from heat to the inside. And then you pressurize it, and that makes it hot, and it makes it move to here. So net, you're moving 2 units of energy from there to here, plus you get the 1 unit of energy that you put in there by the compressor. That shows up in the heat in your house too. So that's how a heat pump works. And so it's heat transfer here, and mass transfer going around. And there's phase changes and other cool things. And because you won't believe in me unless I have a complex picture, there's a complex picture. And it shows how it all works. And if we had more time, I would talk about it. So heat pumps actually move thermal energy, not heat, rather than generate heat. They move energy from one place to another mostly. And there's all these funny measurements of how good they are. And the heat pumps that get the rebates have to meet certain criteria for you to get the rebates. And as I pointed out, this thing that we don't call it an efficiency because we don't like efficiencies that are over 100%. So we call it the coefficient of performance. It's how much you get out compared to how much you put in. And that's another measurement that you have to meet a certain criteria for these cold climate heat pumps. So you people all recognize this heat pump? This is a heat pump?
Yeah, it's a mini split.
Yeah, it's a mini split. Okay.
Not
Now,
the one on the top, very top right corner, that device.
you don't recognize that?
Looks like a lamp. The one above the one with.
This
the
lamp?
top.
Yeah,
Yeah.
the ceiling fixture?
Yeah. that-
Oh, that's okay. I'll tell you about that in a minute. Where do you hope this system is located?
Side of the house.
What region?
Cape's house.
Noisy.
What region of the country?
Cool, yeah.
We have a phenomena here. I don't know if y'all have heard of it. It's called solidified H2O. And it tends to fall from the sky. Now down south, way down south, they don't experience that. So they can put their heat pumps on the ground like this low. This should be on a rack, in my opinion, 18 inches off the ground. So that it doesn't get buried, because the air is blowing this way, actually from there out. And so a lot of people that are just air conditioning contractors will put these on the ground sometimes, because they're used to doing air conditioners which don't get covered with snow, or if they do, you aren't using them for that. And so that's one of the things for you need to look out for one of your contractors. Make sure they get it up off the ground. And somebody said about gable end. It's nice to put it on the gable end of the house so the snow doesn't dump onto the unit. Another good thing. So, why can these things work? I grew up in a house with a heat pump. I grew up in a house with a heat pump.
Is it called an air conditioner?
No, I grew up in a house with a true heat pump. But I didn't grow up in New England. I grew up in Tennessee. And the old wave heat pumps worked okay down into the 30s. But then they frosted up. And you couldn't do anything. You had to run electric resistance heat below freezing. And since it wasn't as cold down there, that might have been practical. These new cold climate heat pumps, these work down to minus 13 degrees or more, or lower. So that's a different animal. And if you're gonna buy a heat pump, make sure for here, and the goal is to heat, get the cold climate heat pumps. Don't buy your standard train unit or something like that. If you want true heat pump, you want to get, if you're going to buy from Train, then buy the Mitsubishi brand that is sold through Train. And if you're going to, there's a whole bunch of different brands that are good for this application. And these units maintain their whole capacity usually down to 5 degrees, and then they begin to tail off at below 5 degrees. And so there's ways you can deal with that. You can either oversize the unit so that it'll still have enough output at the low temperatures. It's not really oversizing, you're just sizing for a lower temperature. Or you can have a backup system, and we're going to talk about that. So these things still deliver good efficiency at low temperatures, and that's the reason they can do this is we use different refrigerants now. We use really high pressure systems, and we have all this variable speed technology and the microprocessors, and so the computer revolution has made a lot of this possible.
How recently were they built? The cold source?
About 15 years ago, something like that. Here. they've been around in Europe much longer. So they're very mature technologies now. You can believe in them. Here's a few brands that are good and the ways to get to them. And there are ones that take energy from air and put it to air in your house. There are things that take it from air and then heat up water, that water moves around your house. And there are things that take energy from the ground and move it to air or move it to water. I'm going to mostly talk about air to air in this talk because that's what the majority of things are going to. I will tell you that things are going to head long term to air to water. And there are reasons for that I can talk about afterwards. It has to do with refrigerants and things. So anyway, this is a very interesting product, Eco Air. And these top three, there are people that represent those here. And some people that do Dayton. I don't know any LG people. I actually don't know any Carrier people in this area. So, what do we care about? We care about money, right? We care about the cost. And realize that an average is some things are lower and some things are higher. You know, and the kind of technology you use matters. But here's an example. If you have a $22,000 system and you take advantage of the $10,000 incentive, that's not a tax incentive, that is a rebate. And it's not just, many contractors will say, I'll get the rebate, you don't ever have to pay it. The other way is you have to pay it and then you get the rebate back later. But many contractors will say, we'll float the amount until we get the rebate. And that's actually a better way for you to do it for yourself, if they'll do it. Because then you don't have to, it's $10,000 less that you have to dole out. Yes?
It says whole house.
I can tell you what that
In
means.
terms of size of house, is there a square footage or cubic footage in terms of?
No. Well, there are rules about single family and multifamily and various rules like that. Whole house is the name, sort of the name of the program, which means that you're going to heat the whole house. You're not going to just heat a room. You don't get the $10,000 if you're going to partially heat. You also don't get it if you put it in with a fossil fuel system too, unless you're really, I'll just say, mostly you don't get it in. If you put in a new furnace with a heat pump on it, you will probably get only about $4,000 or $5,000 in incentive. But there's still real money. So anyway, if you do this and you get the whole house incentive, the cost of the system is $22,000. You would have to pay $12,000 if the contractor will do what it said. Then you'll get a $2,000 federal tax incentive. So it'll cost you net $10,000. There's a seat right there.
Thank you.
And
Is
they
that
can,
pretty much the average
Go around
cost?
the back.
Or just go down to the left.
everybody scoot down.
Space.
Okay.
Thank you.
That's everybody right there. Okay, so long story short, you can get one in if you do the kind of put it up on the walls kind of heat pump, and it works in your house, and your layout matches that. This might be a realistic cost. and then it ended up costing you about $10,000. So now there is another program, and
What's life expectancy on the units?
it's about 20 years, something like that. They can last longer, but it's like air conditioning equipment. How it might be 20, it might be 30. It's not 50. So
Could I suggest that we hold our questions until you're done so we can be sure we get through all of your program?
okay,
Or unless you prefer to do it.
I love the
You like being
interactive,
interrupted, okay, fine.
but I will try to keep it controlled because we do have some to go through. I prefer to be again, I normally teach this in a 7-hour format
Wow.
that's interactive all the time,
Okay,
and people learn more that way, but this is a short presentation, so you may be right that I need to do that. So there is another way to go, which is ground source. You take your energy out of the ground. And that's normally a water loop that goes up and down and circulates water through the ground, and that warms the water up, and then you do the heat pumping kind of stuff that we already showed. The reason that we tend to do the air source is it's about twice as much expensive to do the ground source. 44,000 versus 22,000. But you get a bigger incentive, and that's just recent. That just got started in the last year or two. $15,000, plus you get 30% of the cost for a tax incentive federally. So you end up at about a $20,000 system, and it is more efficient. So it costs less to operate, maybe 40% less. So quite a bit. So what does a heat pump look like? Is it this right here? No, it's not that. Is it that? Is that what a heat pump looks like?
there's a mini zone.
Well, a mini split is a heat pump. Okay. Do you know it also looks like this and 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 this? Okay, here you were asking about the light fixture. This is an inserted thing up in your ceiling, and there's no ducts going to it. There's just tubing. And so you can do a full-way blow in a room and have it in the center of the ceiling. And if you're doing new construction, this is the kind of thing that you can readily do. And if you're doing or if you have an attic, preferably an insulated attic above a bunch of bedrooms, you might want to do this. Okay. And then there are ones that blow out sideways, so they could come out of the wall, or they could be hooked up to ductwork. And this is where I do a lot with ducted systems, because many people, for example, I have an old, and I took this on as a project. I bought a Victorian, and I wanted it to still look like a Victorian after I converted it to heat pumps. So I ducted it all through the floor and have registers coming up out of the floor, and then I just ran 4 ducts upstairs to the bedrooms, and you can, if you came to my house, you could not tell that I had heat pumps. It's just floor ducts. So this is what the Mitsubishi outdoor units look like. If you need less capacity, you get one of these. If you need more capacity, you get 2 of these. And the air blows out of the back, comes out the front. You want the back up sort of close to the house. And
Outside.
Excuse me?
Outside.
Yeah, outside. Why can't you put it inside?
It needs cold. No cold air over there.
Well, it'd be taking the heat out of your own house. And so, okay, so I'm just to show you there are other brands. The LG exists, and it has very similar looking things, except Mitsubishi has this too. This is an air handler, just like a blower unit you're used to seeing for your air conditioning. This thing, so you can run a whole ducted system from it. I just want you to pay attention to this. I don't know why they put this this painting in the middle of all this stuff. I guess they just wanted to make it look good. You know, so, but wait a minute, is that right? Wait a minute. What are they doing? What is this? What is this? Watch this. This thing is a blower. And when you use it, it cantilevers out like this, and it blows. It blows out the sides and sucks in the top, or it blows out the top and sucks in the sides. And it's sort of a gimmick, but it's a way, and it's actually made with a openable cover, glass cover, so you can put a print or a painting in there to make it a little more aesthetic. So it's kind of a funny thing.
And yet, if it works as good as any other, then
Yes, but it doesn't.
it doesn't.
It doesn't. It's because the blowing is not quite in the directions you'd like as much. And it's funny little ears sticking out when it blows. So, but it's okay. Okay, so here, what is this? What do you think this is?
Fossil fuel.
What is it?
Distribution system.
An old existing
Looks like a
furnace.
Is this an old existing one? Guess what this is right here? That's the inside unit of a heat pump. That's the outside unit of a heat pump. And this, yes, is a furnace underneath.
That has been there prior,
No, that's a new furnace.
so they're using a furnace and a heat pump system?
Yeah, they're made to couple. They're actually, this unit is actually made to couple with the furnace, or it can go without a furnace.
So that's the backup, in other words.
It's the backup. And if you have the challenge of a very large house, and you want to have a single system run the duct, if the load's too big, these only go so big. And so this person ended up deciding that they would get that backup just for those few hours that it's going to be colder than this could serve. And also that in the case of a power failure, if this person wanted to have a battery backup system, they can run their furnace. You can't run a heat pump off a battery backup system. So, yes.
So does that still, because I read that if you don't get the toxins that if it isn't your primary, or is it the primary or the only heating system?
Are you talking about tax incentive or the rebate?
The rebate.
Okay. They have changed their, thank you, they have changed their outlook on that to the negative way, that if you have this, they question you having it connected with another system. So sometimes you make choices not just based on incentives. You know, this is my house. I had to do it this way because the load was big enough that I would have had to made a much more complicated system, and there wouldn't have been places to put the ducts and all. And until very recently, they said, if this is able to meet the entire load, which it is almost, then you can have a backup like this, and you can put it up on top of your old furnace. It's what they used to be able to do, and they're mostly trying to push you out of having those. Just one second, having those things. I've been making the case to them that there are reasons to allow some backup, and so I actually succeeded in making my case. But I'm an unusual, because I'm doing this partly as an experimental installation to comparative operating installations. Yes.
So is that a conventional furnace, gas or oil?
Yeah, it's a condensing furnace. It's a 93% efficient, 5% efficient furnace. I think it turned on only recently, because it's automated to not run unless it's way cold. It's automated to run at lead with this and only use the other if there's a need to.
But is it electric or
No, it's gas.
fossil fuel?
It's gas. But, we can do this same system if your load's not too big. You either break it up into 2 units. This one I would have had to have had 2 air handlers, separate ductwork, so on and so forth. And in some ways, it was very complicated to get things where they had to go in this old house. So, so you can't necessarily, and so this is, maybe I'll use 10 days of the year, I might use the gas, you know, if that. So here's a vertical unit. This is the Mitsubishi. This is the kind of thing where you would just get a unit like this and have an air handler in the house, and you wouldn't have anything else. This isn't Mitsubishi. This is Bosch. So there's a bunch of product that does this: the Mitsubishi, the Eco Air, the Bosch, a bunch of others. So yeah.
Are these under the energy saving situation where you know, like a refrigerator has a code on it that?
Oh yeah.
So-
So way beyond.
Oh, it is.
Way beyond.
Okay.
These have to have certain performances to get the incentives, and it's going to do better than the Energy Star. Okay, here's a quick retrofit example. This was a house out in our area here. Existing conditions. Here's the house, old country farmhouse. And one of the spouses was concerned, one of the spouses wanted a heat pump. The other one was concerned about what it would make their house look like. And so here we are, we're showing you the existing conditions, right? Existing conditions. Here you go. You know, so just giving you a feel of what the house feels like, right? Okay. Now, I'm trying to go fast. And then there's still the dog. Okay, so here's after the heat pump system. Okay, see it? There it is, there it is, there it is, there it is, there it is. Oh, there's the heat pump. Right there. That's what you see. A floor duct, a floor register. Not very conspicuous.
Was the baseboard removed also?
No, we just, you can, but. So anyway, there's another register underneath that little table. That's not really a good location, but there's one behind the, see, it's just simple floor registers. It's not intrusive at all. And the dog's still happy. And it wants to be in the house, so that means the house is warm. So I just wanted to show you, I don't know why that's there.
It's a blurry register behind us.
That's true. So anyway, so here's where you start seeing, this is a closet, and there's a duct going up to the second floor. This is a closet that has the door normally closed. This is the door with the clothes hanging on it. You could box that in if you didn't want to see it. That's what I've done at my house, is just sheetrock it in, and so you don't even know that you've got a system in there.
If it's ductless, would you have that?
No,
Oh,
no. The idea was there
so,
was one room we could get it to without having to have a unit in the room, and the unspecified spouse wanted to see less of this in their house. So what we did, now, did we end up getting to do anything with this room?
Is that like a
Right here.
garage?
This is the heat pump head for that room. Doesn't have to be on the wall, it can be down near the floor. Very inconspicuous. So you can do it that way if you don't want to see it so much. Sorry you folks are having trouble seeing. And now can you see where the thermal controls are for this room? You know where they are?
One is digital, one is on the wall.
It's right here.
Ah.
It's like a channel changer.
Oh, it's a remote.
Yeah, it's in a remote. And you can get ones on the wall too, and there's some reasons that you may want to do that because it reads, if you don't get that, it reads where the unit is. The thermostat is inside the unit. If you get one on the wall, it'll read where it is. This is a controller, but not a thermostat. Okay, so let's see, there's your controller, there's the unit. And in one of the other bedrooms here, whoops.
Can those rooms all be controlled individually?
Yeah, if there's an
That was my
individual head, each of these rooms are automatically single control. That's one of the nice things about these heads is it gives you individual control of room by room. Thank you. So, and the dog's still happy. And this is what it looks like in the basement. It definitely makes an impact on the basement. A lot of shiny insulated ductwork.
So are those ducts metal with our insulating surround, or are they?
Yes.
Is that it? Those tubes?
No, they're metal.
They're metal with the
Yeah.
insulator around.
Yeah, you don't want to use flex duct. Too much pressure draw.
Do you ever use existing ductwork?
Yes. Yes, absolutely.
So
Yeah.
you're saying that's rigid ductwork surrounded by flex?
Yeah.
Insulation.
Insulation.
It's rigid ductwork surrounded by insulation. But flex is this springy accordion stuff, and it makes the inside like this, which has lots of pressure, lots of friction.
Resistance.
Yes.
Why would you like to insulate this ductwork when if it's not insulated, your basement will be warm because the heat's coming through that.
Because you'd
But-
like the heat to get to your house.
But then the bottom level will be really cold, and when you have a floor, it keeps the floor cold. I just thought
You can choose to insulate your basement, I mean to heat your basement if you want to, but you should do that intentionally rather than counting on the ducts to do it. Because you want the air that comes into the room. The air is not as hot as a furnace already. So you don't want it to get cooler by going through a cold basement and then go to your house. Now the other thing is, what else are these ducts used for?
Air conditioning.
Air conditioning. And what happens if you have cold air going through a duct on a humid day?
Yep.
And there's no insulation, it'll drip. So your basement will get all wet. So don't do that. Okay, so there we go. And that's what this house looks like. And then what they did, yeah. Oh, and this is what it looks like on the outside. It's just 2 units. Oh, sorry. It's showing me the next one and the first one, so I keep looking at the wrong one. Okay, so here are the 2 units. One out here below the window, and then this one, rather than put it below the other window, they said, let's hang it on the chimney. And so that wasn't my original plan. And they only put them a foot off the ground. I really wanted 18 inches, but there's a trade-off between whether you want to see them or not when you look out the window. So there it is. This happens to be a Fujitsu system. They're very good. Mitsubishi's are very good. There are people that do both of those around here, and they do it very well. Some people around here do Dakin, but I haven't worked with any of them. And they have, this is a PV array, partially offset the load that they have. Since I've done this job, they've put more PV so they can offset. You need more PV than that to run a heat pump system, to offset a heat pump system in that house that size. Okay, what do you want to talk about now?
Yeah, well, I noticed you tended to defer talking about air to water system, but I'm wondering how possible that is in this climate.
Totally great.
Pardon?
Totally great. But air to water, it's easier to do in new construction because you can make the radiators or the radiant floor or whatever able to run on the cooler water that a heat pump provides. But air to water is what's coming. And is what's coming. We're going to shift to air to water because there's a refrigerant issue coming, that refrigerants are being phased out, and as they get, the newer refrigerants are more flammable. So you don't want to run the tubing. There's a pressure to not run as much tubing through houses because it's flammable. We're heading toward propane as a refrigerant. So imagine having propane pipes running around your house. You can do that, but you have to be really careful about leaks or nailing into them, stuff like that. Yes.
So does that mean that if you install an air-to-air system now, it's going to be obsolete?
No, it doesn't. It doesn't. It's a long tail. It's a long tail on this thing. I'm just saying the pressures in what it's going to do is it's going to make air to water be. It improves the popularity of air to water, and the technology is improving. It hasn't been caught up. There hasn't been as much of it in the United States, and it's coming. So both technologies are quite usable for now. Really? Okay. So the last, then what I just want to say here is we can also do water. Thanks for the memory. Okay, so here we go. So here's the kind that you've probably seen. What I want you to know is, you know what the job of this, if you put one of these in the basement, what is its job?
Store hot water.
It's to air condition the basement. It's going to make the basement colder because it's taking energy from the basement to heat your water. So don't be surprised that your basement gets cooler. Okay, half the year, that's going to be a net positive because you're getting air conditioning and you're getting dehumidification in your basement. The rest of the year, your floor above is heating your basement, and then this unit is taking the energy out of the air to heat the water. This still makes some sense because it gets you to electric, and you can get the energy from your house heat coming from a heat pump, and you can get off of fossil.
Doesn't that also act as a dehumidifier?
Yes, that's what I did just say that, but that's okay. Thank you. I'm going to have to plow ahead. I'm sorry.
Just one quick thing is that we have one of those and it sucks the water out of the basement. It dried the basement, half of it.
Right, the dehumidification.
Yeah.
Is what it does. So you can have this done, and then there are heat pumps that are air to water heat pumps, right? What you're asking about. That you could do your space heating with, and you could do your water heating with. Okay? And those would be a unit outside, just like we've seen for the air to air. You put a unit outside, you put a unit inside that heats water, and then use that water to heat your house, or you can use that water to heat a tank of water. Okay, and so there are incentives for these two.
I'm confused by what, are you saying you can have one system that'll do both heat your hot water and heat the house?
Yes. Yeah, if you go to air to water heat pump, you can do that. And then you might have to have a little bit of electric resistance to bump the temperature up just a little bit higher than the heat pump can, air to water heat pump can do. But yes, you can do that. And that's, on new houses, consider air to water these days. It's fine to do air to air too.
What's the limitation on an existing construction for air to water?
It doesn't make hot enough water. You can't put it on your baseboard, because baseboards are designed for 180 degree water, and it's designed for 120. It puts out 120 degree water. And if you heat a radiant floor, you can heat a house with 120 degree water.
Okay.
But if you have radiators, you can't. If you have panel radiators on the walls, you might be able to heat with 140 degree water, or even 100. If you've super insulated your house, you can heat your house with a candle. You know, so anyway, let me just plow ahead here, just showing you how this works. The air blows through here, and then the energy gets taken out in this coil, and then it transfers it down into the water. And okay,
Are there incentives for,
yes, modest incentives for heat pump water heaters. So let's see. Let's just do the flash tour here. Here's what it looks like. Here's what it looks like. There's lots of different brands. I just want to say, if you're going to do a slab, house on a slab, a client that I offered to help and they didn't check in with me, they ended up putting the unit in here between, I'm not going to explain. You have to, if they put the unit between the bathroom and the bedroom, and then they took air out of the hallway to heat the water. And then they wondered why their hallway was cold. And I warned them before they did it. I said, so the big thing is you just switch it to electric only in the winter. There's an electric only switch on these. You can just run as resistance in the winter and then run as heat pump the rest of the year. So I could do tons more things. I just want to mention this. These are the air to water, some of the air to water companies. And there are other ones now. So if you want to go air to water, what I can leave you with is, I advise people to convert their houses or build houses or convert businesses and all that kind of stuff. I'm happy to help anybody do this if they want. I do what I call mini consults, little short consults that get you over the hump. And the one thing I will say about heat pumps is many contractors do not do proper load calculations to size them, and they just guess. And you can't do it by heated square footage of your house, because that doesn't pay attention to how well insulated it is. So I do these load calculations, and that helps you size. And whether I do it or somebody else does it, if you get your contractor, you should ask your contractor, let me see your load calculations. And if they say, I don't have any, then you say, let me see another contractor. So there you go. Thank you very much.
If anybody wants to stand up and stretch her a little bit or anything like that, please feel free to do so. I'm Peter Wingate. I'm Energy Director at Community Action, Pioneer Valley. I agreed to come today because they said Bart was going ahead of me, so I knew Bart would handle all the difficult, tricky stuff. Because let me tell you how I would have explained what Bart just said correctly. I would have said it's all magic. And I would have said, no, let me give you my technical appraisal of it. And I've said this in front of Bart, and Bart chased me down to tell me I was wrong, and I knew I was wrong. But here's how I think of heat pumps. I think of heat pumps as like this little magical border collie that runs around outside and collects all the heat molecules and brings them into your house. I know that's not right, but that works for me. I'm going to back up just a step. What I'm here for today is to tell you how to finance these type of things if you are income eligible. And for us, income eligible in Massachusetts means that you're either on fuel assistance or you're at below 60% of median income or on the discount rate. And it's a really complicated formula. It's free.
Wow.
Yeah, I was saying it's nice to give presentations here because then I think I can have some credibility, because when I say that, it doesn't sound logical. And when we started talking about some of the costs, they averaged $22,000, $25,000 for the heat pump. The houses we're going into, they almost always need work before that. Well, most of the houses we're going into start with a house that has no insulation, has vermiculite, and has knob and tube wiring. Well, we're certainly not going to put in a heat pump. Well, that's all the case, because the heat pump won't work if the house isn't insulated. We can't insulate the house if it has vermiculite. We can't even remove the knob and tube wiring. The utility programs have funds to take care of each of those problems if you're on the discount rate. So if you call us up, we're able to handle those things. We're able to go in and get the knob and tube wiring removed. We're able to get the vermiculite removed. We're able to get the insulation all done. We make sure the house is as tight as we can possibly make it, retrofitting using normal retrofit means. And then we come in and do assessment to try to figure out the best option for a heat pump. And I think one of the things we've seen today is that there is no one-size-fits-all for heat pumps and houses. So one of the things I really encourage each one of you, as you go through your heat pump experience, don't have a preconceived idea that this is what I have to have in my house. When you have contractors in, ask a lot of questions. Do your homework first. If it makes sense to have Bart involved to do a mini consult, this is the time to do it, because once it's installed, it's probably too late. There's a lot of good answers out there. Let me switch back to all of that. That all sounds great, right? So we're going to remove your knob and tube wiring and replace it. We're probably going to have to put in a new electrical panel. We're going to remove all your vermiculite. We're going to get your home weatherized. Oh, if you have single pane windows, we're going to get you triple pane windows. The good news is this is all going to happen over one weekend, right?
Yeah. Average income, 60% of average income, what is that?
For a household of two, that's just under $60,000.
Household of two, 60,000.
It's 59,000 something, something, something.
Is it based on any retirement money? Is that included?
It's based on gross household income.
Just, okay.
Yep. So for more information on how the income is calculated, go to our website, communityaction.us. Most of the people we deal with start by going through the fuel assistance program. It's not required. If somebody's on the discount rate, they don't have to go through the fuel assistance program. But I'm going to say 90% of the households we deal with start by going through the fuel assistance program. I know if any of you have done that, I know the fuel assistance program can be a frustrating process. I know that because I've worked in it for 37 years. This is the first year I've had no official capacity in fuel assistance. I've slept better. It's a brutal program. I could spend the next 20 minutes telling you how they could redo the entire federal fuel assistance program, but I think most of you should get out with me because it would be a really boring time. So I'm going to go back to the community action model. First of all, why does it cost nothing if it comes to community action? And it always goes back to the Green Communities Act of 2008, where money is, each time any one of us pays an electric bill, some of that money goes into a fund to pay energy efficiency. And for people who are on the discount rate, they too pay into the fund, but because they're on the low income rate, they get these things at no cost. If you're not on the discount rate, then they have some really wonderful rebates. We saw that. I was glad somebody was going to ask me if I was going to talk about rebates, and I panicked. I don't remember part of it. It's like, the rebates are great, they're not free. Going through the rebates doesn't mean you can get this work done faster. It's an interesting question. When I'm gonna take a step back. I'm gonna go back 10 years. Had the phone ring in my office, and somebody from the Department of Energy Resources called me up and said, "Hey, would you like money to install mini splits for low-income people?" I said, "Absolutely, sign us up." Click. Went out in the middle of my office and said, "Does anybody in here know what a mini split looks like?" So we've gone from that 10 years ago to now. Last year, we installed a little over 200. And that's not enough. If you look at what the state is trying to do, the goals to really make a difference, for those 200 people, it's great. We think for most of them, it's going to cut back on the utility bills. That's not the only reason to do this. A big push is because of climate change. We're trying to cut down on carbon. So us going from 0 installs 3 years ago to 200 last year, boy, I can pat myself on the back. I try to do it with my right arm. I've done it so many times my shoulder hurts. And it's great for those 200 people, but if we're really trying to get at climate change, 200 households at a time isn't going to get us there. So we're always trying to find a way to rethink this. We started off with one contractor that we trusted, and now we just started building up a stable contractors. And then on our end at Community Action, we started out with me going out with the contractor because I had a contractor I trusted, and everything we did, we consulted with somebody else to make sure we didn't screw up anybody's house. That was always our #1 goal, not make it worse than when we got there. And then we started bringing in more contractors at a time, having more of our technicians. What we do is our version of a mini consult. I'm not saying that we have a bunch of Bart Bales. Bart, we should talk, maybe something would work. And I'm only half kidding, because we do run into some houses that are really tricky. But our model is that we walk the house with the contractor that we're pretty sure is going to be the installing contractor. Then we get a proposal from that contractor, we look at it for reasonableness, and then before we say yes, it's sent to the funding source, and our funding sources are either National Grid or Eversource, so certainly here in Greenfield, it would be Eversource. They too look at it to make sure it looks reasonable. So we would give them the load calculations, we would give them the costs and what units are going in, we even give them a sketch of where the individual heads are going to go, or what's going to be there for ductwork. So then another person looks at it and says, does this look reasonable? If it looks reasonable, then we go ahead with the proposal. Up to this point, we're not doing competitive bids because we really want to make sure contractors are more concerned about getting it right than winning a bid. I don't know if that can keep going on forever because these things are expensive and we are using ratepayer money. So right now, we're going to keep doing it this way, working with contractors we really trust. At some point, for you all, if you're going through the rebate program through Mass Save, I'm guessing it might not be a bad idea to bring in a couple of contractors, get a couple different ideas, get some different price points. And again, don't want to speak for you, but I'm guessing if somebody has 3 different proposals, there might be a way to consult with you or somebody else that help walk through that process.
Yeah,
and figure out the
I'll
best way.
review proposals for people if they want.
So again, just can't stress enough, but don't figure out that you went to your friend's house and your friend has a system that they like really well, might be perfect for the house, might not be perfect for your house. Personal, I did not grow up with heat pumps. I grew up in Iowa. It's cold in Iowa. But I do have one in my house. I've had one, just a single head system I've had in my house since 2016 or something like that. And got it very much, I use it, it takes the edge off in the shoulder months. This time of year, we might turn it on once in a while as a space heater, which is not the way to use these things. But it's, once in a while, my wife and I are sitting on the couch, and the kids are all gone, and we've got a nickel more in our pocket than we did when all the kids are around, so we might turn it on for reasons like that. It's not the way the mini splits are really made to work. Again, I don't want to step on Bart's toes, and I'm sure you'll interrupt me if I get this wrong. What can also be tricky for those of us who grew up being frugal, turning the heat way down at night to try to save some money, and also because some of us like it nice and cool when we sleep at night. The heat pump technology really works better to maintain heat, not to let it drop and bring it back up. So it's also a lifestyle change. You set the temperature and forget it. Again, I've been doing energy efficiency since 1987, so it just pains me to think of telling people, no, you just keep your heat the same temperature. It's so ingrained in me saying, no, turn it down at night, turn it back up, be careful, all that stuff. That's not how this technology works. It does a better job. I keep looking at you because I really want you to correct me anytime I'm wrong.
I don't agree.
You don't agree? Oh, good. Is there a quick?
I've heard people who are pretty smart people suggest that. I think the bigger point is one of comfort than it is of energy efficiency, because the heat pump can't bring the temperature up as fast as you're used to from something else. And so if you get down low, it takes longer than you probably are going to like to bring it up. If you have it on a timer, on a, smart thermostat, and you'd have it heat up before you need it to be warm. If you want to be warm at 7, have it heat at 6. I need to run the numbers, but it doesn't, I don't, looking at the load tables and stuff, I don't think it's right. But it may be that for comfort, people are telling people to do that because they're going to be uncomfortable and the walls are going to get cold and it's going to take a long time to warm it up, and you've designed, and if it's a small house, if it's a house that's super well insulated, there's not that much benefit to setting back. There's not the same benefit that there is to in a less efficient house and stuff like that. So I still set back, but I wouldn't, the trade-off is if you set back, then it's having to make up the heat during the coldest part of the day. But say you're leaving in the day, you're going away in the day and you're coming back, it's still equally warm as it was when you left. The heat pump's it's got to save energy in that case. The only reason they argue that is because they're afraid you're going to start your heating back up at the coldest part of the day, and it's going to be working against a worse of a temperature difference. What I would say is don't set it back as far. I would tend to set it back maybe 5 degrees, 7 degrees, in old school stuff, we would always say, like school buildings and stuff, set it back to 55 at night and then bring it back up to whatever your operating temperature is, 68 or 70. There's not agreement on this subject between even me and another really good engineer who is known in circles. So I've heard it argued, but I think they're doing it more to encourage people experience with the technology than they are for energy efficiency per se. But that's not definitive. That's an opinion.
Okay.
Oh, this fits into this, I think. So I've had a heat pump since 2013. Heats the whole house, but the house is very one bed, 1,250 square feet. So small house, okay. What we did is the electrician set our thermostat so that it just kicks in when the temperature drops down to like 61 or 62 or 63. So the heat pump keeps working. It's one head, remember, keeps working. But if it can't keep up, then we still had an old furnace in there. It wasn't an old furnace, but and we're using almost no oil, almost zero. It only kicks in when the temperature drops to about 0, but your pipes don't freeze.
So that's a little bit what I heard you have set up at your house, that in theory it could get cold enough outside that there's a sensor that'll flip over to the fossil fuel.
Right.
And hoping that it 3 or 4 times a year might be all it needs to do that.
Another thing is, we are, because I've got a description of what we did in here, 1 page. Another thing that we did is that that it's important to note is we have the solar collectors on the outside. We got a huge rebate off the solar collectors that was used by the heat pump for $1,000. Now, the thing is the solar collectors generate the energy to run the heat pump, making our electricity and heat $450 a year. So I think it's worth trying to figure out all the complexity of getting the house really well insulated, then use the rebates are so good right now. I don't know how long they'll last. Yeah.
So we're
There's a question over here.
Q&A mixed up with the, do you have enough more to go?
No, let's just jump right into the Q&A. I think we're good.
You all right?
Absolutely.
Okay.
There's a question over here.
Let me just chime in with one really important thing that I didn't include, and everybody should know about this. It's the zero interest heat loan.
Yeah.
And you can get up to from some banks, you can get up to $50,000 toward a heating system at 0 interest, 7-year term. Some other banks are only going to 25,000, but there are no strings. It's basically you're getting to borrow the money and then pay for your system on time with no interest, and that lets you get over the hump that you can actually get the heat loan before you have to pay for the system that you've gotten quoted and installed. You can pay with the heat loan and not have to have that out of pocket expense. So it's really a powerful, wonderful, incredible tool. You should know Massachusetts has been the leader in the country in all this kind of stuff for 8-10 years or something now.
Yeah, I have a couple things. One, I just did this like last week. I got mine installed, and the heat loan, you should know, you have to get it authorized through Mass Save, and the check is gonna go to the contractor. You're not just gonna have the money in the bank, and then when you get around to it, you can pay it. It's gotta be approved that it's the cost that you need the loan for. But my other point is that I was told, and correct me if I'm wrong, that starting 2024, you have to disengage your previous heat source in order to get the rebate. Is that true? Because I just got in under, 2023, but I understand that, like as Pam said, often people do need to have their pre-existing heat source just in case it gets too cold or their house isn't insulated enough. So can you speak to that? That it seems like a disincentive to me that they're saying, get these mini splits, but then just disconnect your fuel heat.
I think that's relatively certain that is only if you want to get the $10,000 grant, and that if you go through the ordinary incentives, not the whole house incentives, that you can also do the heat loan. So the heat loan, I don't think is dependent on what you're saying.
I was two different things.
The incentives are dependent.
The
No,
rebate?
it's the other way around. They're incentivizing you more if you'll disconnect.
Okay.
It's not that they're withholding what they would have given you anyway. They would have given you $12,050 per installed ton, which means nothing to anybody. But you'd get a 3 to 5 ton system in your house. So you'd be between $47.50 and the higher number for your house as a rebate. And you can get this bigger incentive if you decouple. I was under the impression you could retain your backup system as long as they weren't interlocked to automatically turn on. So that's where I believe it is, but that's a little murky there. It's been in flux and changing.
I just didn't know if the heat pump technology fits, like in this area where it gets so cold, to be able to completely not have your other heat source.
Yes, you absolutely can, particularly if you've well insulated your house. What you may have to, there's two things we can do. With the ducted system, you can have an electric coil put after your heat pump. So that in that super cold time, you can use the electric coil in addition. So for a ducted system. For the other kind of system, you can size bigger so that the rated size of the heat pumps is still big enough. Because they'll put out 80% of their rated capacity at -13. So if you just size based on that, you could get by that way too. There's a bunch of tricks. Yes?
I wanted to tell you about the heat pump. The idea is when you lower the heat, you turn it down the temperature. What happened, I know that what they have is that the machine understand the temperature inside. And what they do, they reuse the temperature size to regain not from zero, but from the temperature that you set it. Okay? If it's 22, every time the machine will refurbish the temperature inside, not from from each side, then it starts 22, and vertically or it is low, and you go into the pump again, and instead going to a zero, or when you lower it down, you know, from the point B. At that point, because sorry, I'm a little nervous. The idea is that the one I have is always on, continuously, okay? What happens is, when you put the temperature, it will go on and off. Okay? But the idea is, you put it in a temperature that is practically very, very comfy, not too hot. What happens is, that temperature stay all the time, because the time the detectors go down a little bit, the machine go on again. Practically consuming very little, and they stay there all the time, all the time, all the time, all the time. Instead going to regain from 10 grades, it's go from 1 grade, and you start again. And you start again.
And what's happening is the maintaining of the temperature higher makes your house lose heat faster. So it's a trade-off between how much do you lose at 70 versus how much do you lose at 60. And that's a function of the difference between the temperature of the room and the temperature of the outside. So you're getting a big savings by dropping the temperature. So go ahead.
Yes, in the sense of what we've talked about all this morning, the one key here is electricity. And the key is, if we lose electricity, the heat pump becomes zero, correct?
Just like for your boiler or your furnace.
So we have a generator now, we just installed a generator and all that, and the electrician said, where do you want to go? We have a steam boiler, so we had that as a primary hookup. And the heat pump.
Just 1 sec. Did you have a question before you were leaving? Excuse me? Did you
No,
wait?
I'm
Did
all
you have a
set,
question?
I'm
Okay,
just
I just wanted to keep
Well,
going.
anyway, does the generator actually operate a heat pump?
You would have to have a very large generator, so that's why that was my argument for having a backup that you could use during power failures, which are not very frequent. So what you would have to, if you're gonna run on just the heat pump, you're gonna need a very large generator to keep that heat pump going. That said, if you've got a really well insulated house and the power failure is only for 7 hours or something, you're not going to lose much heat in that amount of time anyway. So it's this whole thing of, it depends on where you live, what makes sense. You know, if you I live in Greenfield, I'm not going to lose power very long, I don't think.
Well, I guess what's happening now, everybody's worried about the atmosphere and the intensity of storms and all that kind of stuff. So there might be a possibility with a larger outage for a longer time. And also, I know, I used to work for the electric company, they're downsizing in sense of the ability to, they bring in extra crews to actually go into an area that has been affected.
Right.
But in the offset, you know.
No, that's all, there's a lot of complexity to how to think about this. But what I will say is I think overall, the policy to convert to heat pumps is the right way to go. And there are ways to protect yourself against the lower incidence, high impact things like power outages and stuff. So
And it does tie into the whole, we haven't talked about electrification, that would be a whole other hour at least. But modernizing the grid and trying to cut down on how long people lose power and losing power less often. This is also a long-term process.
yeah, it's all, okay, I think it's your turn.
Okay, well, we talked about heat pumps generating heat. Don't they also do air conditioning?
Absolutely.
Okay.
That's
Did you
so
have a
great.
question? Okay.
Okay, well, what occurred to me is that insulation is actually a lot cheaper. Really, really good insulation. And so I think it should be done first, because once you insulate a lot, now you size differently. You size the heat pump differently, everything gets sized differently. If you do the weatherization and insulation. But the trick is, if you're gonna insulate really tight, you have to get the water out of the building, because you don't want mold. And you have to do all the things like knob and tube wiring. You have to do first, because you're not gonna cover old knob and tube with new insulation or something like that. So my house is R60, and that means that I can heat the house, he said, with a candle. Well, one head, one
Let me just say,
and he's seen it, but he's got questions about the way it's done, but, you know.
no, I'm not gonna speak to that. I'm gonna speak to the things, I used to teach a workshop or a talk. It was called the 3 R's of sustainability. And that was reuse or renovate, meaning use an existing building. Then retrofit, which means insulate and air seal. And then renewable. And under retrofit would be new, like heat pumps and all that kind of stuff. To make you make the shell as good as you can, then you make the stuff that's using energy in the building as good as you can, and then you add solar to do that. So that's a normal sequence that everybody should be thinking. A lot of people say, I want to do something good, I'm going to go get some solar panels. And it's a good thing to get solar panels, but it really does make sense. And wonderfully in this state, you've got the Mass Save program that promotes insulation, that won't let you insulate unless you fix your knob and tube, won't let you insulate if you have a mold problem. You know, so they're sequencing things right. They're letting the programs encourage you to do things in the right order. So that's a good point.
Let me interrupt for a minute. We promised, I think at 1:15, conclusion of all this, and it's about 1:15 now. I suspect that maybe these gentlemen will be willing to stay a bit longer for more questions, but if anybody would like to leave at this point, don't feel bad about it. We're glad you came and we thank you for coming.
Just a quick note on eligible programs, go to communityaction.us that has the guidelines on there, or call my agency, and if you think you might be eligible for these 3 programs, again, going through me. Doesn't mean that we're going to be at your house next week, but you heard all the things we can do and there is no cost, so to my mind, it's worth the wait.
Where are you located?
We're at 393 Main Street, in Greenfield here.
And if anybody wants a one-page description of what we did, soup to nuts.
I want to say, I know some people may want to go, but I was under the, I was asked to be here for an hour and a half. So I am totally expecting another 15 minutes, but if you all want to leave, that's fine.
Good.
I want so we did go through Mass Save, and they required the installation, and we did do the whole house. And they did not require that we got rid of our backup system because we had an area where we couldn't do it in this. There was a room, it's like, so,
Did they give you the
and we
10
got
pounds? That was a year or two ago? Yesterday?
October.
Yeah, I think, Bart, you're right. We're going to 1:30, not 1:15.
Right.
So,
I just want to say something before people leave. If anybody wants any help, I've got cards here, and you just feel free to grab one of them.
oh, you have a question in the back?
No, I just want to cry.
Go back over there. Yeah.
I just wanted to offer that for me, in terms of describing what a heat pump system is, a really good way is to refer to the refrigerators that we have in kitchens. It's the same technology.
Were you here when we talked about that at the beginning?
I must have missed it, I'm sorry. Well, I wanted to just emphasize that point.
You two are equally brilliant.
So the first thing to do is to get Mass Save to do the installation and get in there, and
Yeah.
that's the first step.
The first step is to have an energy audit, a free audit by Mass Save. And you have to do that before you can use these other programs.
Okay.
And then that'll let you get the insulation stuff. And it also is necessary to get the heat loan and the rebate stuff, as far as I understand. Tim?
Do you know what the timeline is between, so how recently would I have needed to have the energy assessment?
2 years.
3?
2 years. And the new audits are way better than the old audits. You want the new audits, because they'll cover way more than they used to. So I mean, it's not the, hey, let's give you a few light bulbs and a shower head kind of audit. It's, you know, it's insulate all your walls, blow insulation into your walls.
Do they include an infrared reading of the?
They do not.
Oh.
They do not normally.
We have a question over here, Bart.
Over where?
Here, oh.
Oh, yeah.
So I just got something from Eversource about energy efficiency, and I'm wondering, is it better to call Mass Saves or go through Eversource, or to have the audits, or, you know?
You're gonna end up with Mass Save anyway.
Okay, so okay.
And if you really wanna make them feel good, you'll call it Mass Save
Oh, okay.
and leave the S off the end.
Okay.
No, it really upsets them if we do. That's a joke.
You had your hand up a little.
I think you're,
They're pointing to you. Oh, I'm sorry. I don't see well. What if you have Berkshire Gas and they won't do an energy audit? It's complicated. I have Berkshire Gas, and Mass Save would not give me an energy audit, saying Berkshire Gas had their own people do it. But Berkshire Gas either won't call you back or tell you what to do.
that's very unusual. I didn't know that was the case. Have you, and you're on Eversource?
Yes.
Just go through, you should just, I don't understand that. Mass Save should, the Eversource side of Mass Save should be doing an audit for you.
But natural gas is your primary heat?
Yes.
Try calling Central Eco Technology. They're the ones who used to do the audits for Berkshire Gas. I don't know if that's still the
I don't think
case.
they are anymore.
They're not anymore? That's unfortunate.
I've been trying to get an energy audit for several years and have emails that
Do you live in Greenfield?
Turner's.
Turner's. I don't see any reason that you shouldn't be getting that. That's strange. So, let me get your information, or you send it to me, and I'll see if I can be a go-between to get that done.
So,
Because I've known some people in that.
along this line,
Somebody else.
I
can-
had called up Mass Save.
Somebody else can do that for you.
And then I got a phone call from Mass Save that said, this is your natural gas, there's somebody else. And unfortunately, I lost that phone message, so had to call them yet.
Yeah, we had the same experience here at the church. We wanted to do an energy audit, and because we were primarily on gas, somebody else did it. I've forgotten all the details, but I remember there was that interruption. Maybe because we're not residential, that was the case, but I'm not sure.
It might be Rise Engineering.
It might be, that does sound familiar.
That's what we went through, so it was not safe right then. Yeah.
And then Rise Engineering, yeah.
Yeah. But we should have.
But I didn't get all the way through.
Okay.
Hi, so if you now use basically wood or gas or oil or something like that for your heat source, and you switch to a heat pump, would you see a significant rise in your electric bill?
Of course.
Yeah, and how significant? Because electricity, I'm just amazed at the cost of electricity.
Did you say you're on gas or oil?
Well, we have oil, but typically we do use wood heat.
Yeah, I don't know what it depends on your cost of wood for cord and all that kind of stuff. The heat pumps are really competitive against oil and propane.
Okay.
And it depends on the electric rate and the gas rate, how you end up around comparative economics. What I will say is, if you're worried about payback, that the payback, if you include the cost of all the pumping energy that it will take to keep the ocean off of the East Coast, it really works out really well.
They're gonna move here.
Let me have a plug here for our Green Team program here at the church. And that is that next month, the third Sunday, we're having someone talk about solar panels. And I think it's accurate to say that very often people who are moving to heat pumps also like to install solar panels if they can, because that helps pay for the heat pump. And so come about a month from now and learn about solar panels if you haven't already done it. Is that okay, Ellen?
That's excellent.
And if you have some beautiful trees in your yard, there's often some community solar options that might be better than cutting down a tree. So hopefully
Right,
they'll
yeah,
cover
you
those
can,
as well.
you can buy into existing arrays. And you should realize that Greenfield electricity is already renewable. So you're running renewably on a heat pump here. Unless you've opted out, you've got green electricity in Greenfield, is my understanding.
A certain percentage.
I think
Not
they-
No, it's 100%.
In Greenfield, 100%? Really?
Yeah, they bought into.
Thank you, Carol Collins.
Yeah,
Well,
they,
is it a program that the whole city board?
yes,
Unless you opted
Unless you
out.
opt out, yeah.
yes. So
Peter, you mentioned, calling community action for light removal and installation. What's the flow? Do I call you? Do I call Mass Save? Do I?
If any of your fuel assistants are on the discount rate, I'd recommend call us directly at 774-1140. We have 200 numbers. You can tell all 200 whether they're on the brain at the same. Let me say it again. 774-1140.
And that goes to community action.
That goes to Community Action Energy Department. My program will be answered by Amanda, Sienna, Nancy, or Corey. Not Corey, another Corey. Or you can come down and answer phones if you want. We're in the same day.
yes.
Yes, do either of you have any materials that you could, let the green team have, so if anyone comes to ask about it, we can show it to them or share it with them in some way?
What do you mean by material?
Materials like a pamphlet or cards or,
Got cards.
okay. Pamphlet, great.
My website, balesenergy.com,
Okay.
leads to a little bit more
Okay.
explanation of what
Great.
you can get help with.
Thank you. Well, the reason I was asking about electricity is because we do have solar panels, and this year, for the first time, we're having to pay for our electricity bill, because of course we had no, much solar gain last year because of all of the wet summer. And, if you just have Eversource, this is an electric pump, but if you just have Eversource and you just have whatever they have, you have the most efficient things. You always get these things in the mail and say, switch to us. You know what I'm talking about?
Yeah, if you're switching, be really, really careful. Make sure you understand every word in the contract. There are some historically bad actors out there.
Right, that's what I
So
thought. We
just-
haven't switched, so we figured that Greenfield was probably just the best.
If you're on Greenfield already, then
If we just have whatever Eversource has, yeah.
no, if you ever have whatever Greenfield
Eversource.
has.
Yeah. So we just have to call Eversource and say, are we on Greenfield's plan?
If you're in Greenfield, you're on Greenfield's
Okay,
plan
got
unless you opted out.
Perfect, that's what I'm.
It's on your electric bill. We're from Deerfield, and they have a clean energy, automatically, you could sign in with Deerfield, so it's probably the same with Greenfield. But it says it right on ours, it's Dynergy. So,
But I'm sorry, in Greenfield, you're already on automatically.
Right.
You only get off if you ask.
oh, okay, so that's.
We asked one time if that
Oh, I didn't because I have nobody else. I have a question. This is a little unusual. So we do have a separate for my mother-in-law. We put in an addition for my mother-in-law with radiant heat, and then also a mini split. And she loves to keep it at like 75. So my question for her is she offsetting? Is it more economical to increase the radiant heat temperature, or for her to just really ramp it up with the
What is your heat based on?
oil. The radiant heat is oil.
Probably you're okay using the heat pump.
So really, yeah, okay. She goes,
So these questions always do come down to what is the rate of oil? Remember last year when we started the heating season, oil was $5 a gallon or more.
Right.
Whereas this year it's been better. I should know, I don't know what the cost.
Yeah, there is a way to, calculate the cost per energy unit through both things and look at the break point and all that kind of stuff. But do you only make your decision based on economic payback, or do you make it based on values?
I
And
need to make values, but she.
Fossil fuel.
well, she can be just
Greenhouse gas.
she can be just as warm either way. The one thing is,
No, she's not. She loves the.
is it radiant floor?
Yeah.
And it's oil fired hydronic? Yeah, that will feel a little warmer because the air's not moving.
She loves the air moving from the mini split.
Okay, then you should just turn the temperature up on the mini split. And maybe even turn it up a little bit above what
She
you
does
want the
that
room
very
to
well.
be.
So
Yeah.
Friday mornings, we have a technical round meeting where all of our technicians don't do any field work. We come in and yell at each other about how to do all the stuff we're talking about, because sometimes it's not simple. One of my younger technicians the other day said something that I thought was brilliant. Said, once in a while the answer is not just $4,000 worth of insulation, it's $400 in a pair of slippers. So comfort is so critical.
Yeah, there's this new product out, and it's called portable insulation. And portable wearable insulation. It can be made out of natural fabrics, or stuff from animals, whatever, made out of plastic.
There's a question back here that I also have, and I think you covered it briefly, but we will stop pretty quickly, but it's whether if you have a forced hot air system now on, oil or gas, whether all of that ductwork can be used for a air source or water source.
Typically, yes, with one proviso. You can absolutely use it for heating. If you want air conditioning, then you'd be better served at least in the basement to insulate it, because otherwise it's going to drip when you air condition. And the parts of it that are in the wall may or may not drip. It depends on how much humid air gets up in there. But ideally you would insulate it. The other thing is that occasionally you will run into ductwork that's too small. And so you won't be able to deliver the full load that you might need to. And that kind of thing can be answered by something called a load calculation, which I was talking about earlier. And a load calculation is actually room by room loads. And that number gives you how much air you need to heat that room, how hot. And that can all work backwards to figure out whether the heat pump, but the general answer is yes.
I think you suggested that if you have a problem about the upstairs air conditioning, you could just not use air conditioning upstairs and only do it downstairs.
That's true, but what you could also do is to put heads upstairs and put ducted systems downstairs. That's the neat thing. You can mix and match these. You can have an air handler and a head and so on the same outdoor unit, or you can have separate outdoor units to do separate things. There's a whole lot of different ways, and it depends on the configuration of your house what makes sense, and your own aesthetic sensibilities matter too. If you've got a really good open plan living room, dining room, kitchen kind of thing, and it's pretty well insulated, you can just use a head and get that area done pretty well. The other way is you can just use a ducted system from underneath, and then you get it distributed so it'll be even around the room. So either one can work, but if it's really open and really well insulated, a good sized head can do pretty well.
So the planning up front, not having made up your mind before you have people come on and look at the house with you. There are different options. No two houses are the same. There's probably two houses that are the same. But probably none of our two houses in this house are the same. So be flexible, find out what works best for you. Get help if you need it. See more than one contractor, get bids. Take advantage of these.
Get load calculations.
If you can
Get
come
load
through us,
calculations.
it costs nothing.
Get load calculations.
These things work. This is what they put in northern climates in Europe. They've been doing it for years. They're ahead of us. These things work. You don't have to be afraid of the technology. I'm so glad you started with refrigerators, because that was a great way to start today.
Yeah. So now we are at the end. Nobody has to leave, but I do think I should announce that we're at the actual time that we talked about. And